Good morning, everyone. So let us begin. Last time we were discussing week 11 summary, and then we were discussing to find the Laplace transform of minus e raised to the power of minus 80 u of minus t. A here was given to be greater than 0. So we used the Laplace transform formula, which was xt e raised to the power of minus st dt integrated from minus infinity to infinity. We substituted and then we came back to this step. Are you able to recall this?
Yes, ma'am.
So now we had a confusion that when we put t is equal to minus infinity, this exponential will go to infinity, right?
Yes, ma'am.
Now let us look at it closely. So we computed ROC where we said that real of s is less than minus a. A is a positive number, so minus a is necessarily a negative number. Is that clear?
And can you say it again?
So we had the condition that a is greater than 0. If a is greater than 0, then minus a is definitely less than 0. Can we say that?
Yes, ma'am.
So now let us come back. Here, real of s is less than minus a. All right. Now let us come back here. So this this altogether will be a negative number. This is negative and this is negative. So negative into negative will become positive. Now when we put t equal to minus, t tending to minus infinity, then it will be a raised to the power of minus infinity only. So that will go to 0. Is that
Okay, ma'am.
is that clear?
Yes, ma'am.
Diksha, Rohit, is that clear?
Yes, ma'am.
All right, now let us start the problems. For the question 1 and 2, this figure is common. We have a signal xt, which is shown in this figure, and xj of omega is the Fourier transform of this. We are asked to find capital X of 0, that is the value of Fourier transform at frequency equal to 0. So maybe I'll give you 3 minutes. You take 3 minutes, you solve, then I will start solving. Start. Question is clear now?
Yes, ma'am.
Okay, solve. Jay, so we are discussing first question only. The signal xt is given. Capital X of j omega is the Fourier transform. You have to find the value of Fourier transform at omega equal to 0.
Okay, ma'am.
Did anybody solve?
No, ma'am.
Ma'am, 40.
No, it's not 40. So what approach are you guys using?
First, I put the at omega equal to 0, then integration will become minus infinity to infinity x of t dt. Then I find the area under the curve x of t.
Yes, your approach is correct. So probably you made some calculation mistake. So let
Oh,
us see how to do it. So we have this signal xt which is shown. We have to find the
ma'am,
value.
44.5.
No, it is not.
Oh, okay, let me check.
So we have to find the value of Fourier transform at omega equal to 0. So let us see this equation. This is the Fourier transform equation. We will substitute omega equal to 0 here. So I put omega equal to 0, then I get capital X of 0 is equal to minus infinity to infinity xt dt, because e raised to the power of 0 will become 1. Is this step clear? Class,
Yes,
is this all right? So now what we have to do is we have to find the area of xt. Area of xt is this area. So what we can do is we will first consider this rectangle, find the area of this rectangle, and then subtract the area of this triangle. So let us see. First, let us consider the rectangle. Let this be the length of the rectangle. Let this be the width. So can someone tell me what will the width be? Sorry, the length be this one.
5. 9 minus 3.
6.
Yes, it will be 6. The length is 6, 9 minus 3. Now let us find the width of the rectangle. So tell me what this will be. Yes, it will be 8. So now we have the area of the rectangle. Let us subtract the area of the triangle. So for this area of triangle, I can use, yes, Jet, now that's correct. So now we will use for the area of triangle half into base into height. Half base, tell me how much is this?
1. 2.
Yes, 6 minus 4, 2. Base is 2. Tell me the height of the triangle.
1. 8
Yes,
minus 7.
8 minus 7, 1. So we have 48 minus 1. So we get 47. So the value of capital X of 0 is 47. Is this clear?
Yes, ma'am.
Yes, ma'am.
Diksha, Rohit, is it clear? Okay. Now the next question is also based on this. So you will have to use this figure. What second question you have to find capital X of j omega d omega integrated from minus infinity to infinity. So it's like now you have to find the area under the Fourier transform. So I will give you a hint. You can try using the inverse Fourier transform equation for this. Since you will need the figure, so I will just write the question 2 thing here. Is the question clear?
Ma'am, can you explain a little bit?
So this is what you have to find in question 2. Is the question clear?
Yes, ma'am.
And the hint I gave was use the inverse Fourier transform equation for this. Take 2 minutes. Start solving now. Just wait for 1 minute, then you can tell. Okay, now Jay, tell your answer.
I think 94 pi.
No, no, no. All right,
Okay.
now let me start solving. Everyone, please pay attention. So here we will be we have to find, this is like area under the Fourier transform curve. So what we will do is, let us write the inverse Fourier transform equation. So xt is 1 upon 2 pi integration minus infinity to infinity x of j omega e raised to the power of j omega t d omega. Let us put t equal to 0 in this equation. So I have x of 0, small x of 0 is equal to 1 upon 2 pi integration minus infinity to infinity capital X of j omega, and e raised to the power of 0 is 1 d omega. So if you see, yes, yes, that's correct, Ananya. Yes, Jay, that is correct. So now in question, I wanted to find this. So this will be equal to 2 pi times x of small x of 0. This integral is equal to 2 pi times small x of 0. Let us go back to the curve. What is the value of x at t equal to 0? It is 0. Is everyone able to see this?
Yes, ma'am.
Sonali, Jay, Diksha, Rohit. Okay. So the value of x at t equal to 0 is 0. And if I substitute 0, I get 0. So the answer of second question is 0. Is that clear?
Yes, ma'am.
Okay, now let us move to the next question. So you have an LTI system, a continuous time LTI system. The impulse response of the system h of t is e raised to the power of minus 3t ut. The input to this LTI system xt is equal to e raised to the power of minus 2t ut. You have to tell me the output yt. Is the question clear?
Yes, ma'am.
So I want you to first solve it by Fourier transform. Convolution will be lengthy. Fourier transform method will make it easier. Find the Fourier transform of both of them. Do partial fraction. And once you get it as two fractions, then find the inverse Fourier transform. So first you do it by Fourier transform, then we will see by Laplace transform. 3 minutes should be fine for this.
Yes, ma'am.
Okay, start solving.
Ma'am, after getting the hj omega and xj omega, they will get multiplied.
Hmm.
Okay.
Did anybody get the answer?
Yes, ma'am.
Okay.
Yes,
Tell
ma'am.
tell me your answer.
E to the power minus 3j omega ut minus e to the power minus 2j omega ut.
That's not correct.
We have
Okay.
to tell in the YT, right? In the
Yes,
time given.
YT, YT.
That it should be e to the power minus 2t minus e to the power minus 3t u of t.
Yes, that's correct. Okay, so now time's up. Everyone, please pay attention. Let us solve it now here. So we have been given an LTI system. So for LTI system, we know that output is equal to input convolved with the impulse response. Okay, okay. So in LTI system, we have this convolution relation. When we go to Fourier transform, according to the property of Fourier transform, the Fourier transform of xt and ht will be multiplied. So this is what I mean. Yj omega will be equal to x of j omega multiplied by h of j omega. Is this clear?
Yes, ma'am.
Now let us find xj of omega. So xt was e raised to the power of minus 2t ut. Its Fourier transform will be 1 upon j omega plus 2. Is this clear? Fourier transform.
Yes, ma'am.
Similarly, we will write the Fourier transform of ht, h of j omega, which is 1 upon j omega plus 3. Now we have the Fourier transforms. Let us multiply. Now we will do partial fractions. So after partial fraction, I will have this. Is this clear?
Yes.
Now let us find the inverse Fourier transform. So yt will be equal to e raised to the power of minus 2t ut. Next term minus e raised to the power of minus 3t ut. If I write it together, it will be like this. Is this clear?
Yes, ma'am.
So this was by Fourier transform. So just like in Fourier transform, now we have a similar property in Laplace transform. So if yt is equal to xt convolved with ht, now we are doing it by Laplace transform. So yt is xt convolved with h of t. In the Laplace transform, we have the similar property ys is equal to x of s multiplied by h of s. So if in time domain there is convolution, in Laplace domain there will be multiplication. Is this clear?
Yes, ma'am.
Now my xt is equal to e raised to the power of minus 2t ut. We computed the Laplace transform of this last time. So it will be 1 upon s plus 2. And yes, we have the ROC, which is real of s greater than minus 2, is it? Yes. Is this fine?
Yes, ma'am.
Yes, ma'am.
But now let us not really look at ROC because we know that these are UT, so right-sided signals, causal signals. So I have X of S. Similarly, I will have H of S. HT is e raised to the power of minus 3t ut. Tell me the Laplace transform of this.
1 by s
1 by
plus
s
3.
plus 3.
Yes, 1 by s plus 3, similar to the first one. Now, if you see now, so in this um, here, x of j omega is 1 upon j omega plus 2. Here it is 1 upon s plus 2. So basically s, since the Fourier transform exists, so s is equal to j omega, and this is what we have. So instead of j omega, there is this s. So in writing, this is more compact than Fourier transform. Like instead of writing j omega, writing s is more comfortable, right?
We are comfortable with j omega also.
All right. I find this s thing more comfortable. So now we will multiply x of s and h of s. So I have 1 upon s plus 2 multiplied by 1 upon s plus 3. I don't know how do you do partial fractions, but for these kind of functions, there is an easy method. So I will just quickly discuss it here. So now I had this, I wanted to do partial fractions for this. So there are two terms in denominator. So I wrote them this, and this is what we have to find out. So what we will do is now for the numerator of this, we will put s equal to minus 2 here, and this same term s plus 2, I will ignore that, and in the remaining thing I will put s equal to minus 2 to get the numerator. Are you able to follow what I am saying?
Yes, ma'am.
Okay, so we are finding the partial fraction numerator for s plus 2. So I will put s is equal to minus 2 here in this red thing inside. So it will be 1 upon 3 minus 2, which is 1, right?
Yes, ma'am.
So I have this numerator here as 1. Now let us do it for the other one. That is s plus 3. So I will put s is equal to minus 3 in the remaining one. I will ignore the same term. So I have 1 upon minus 3 plus 2. Minus 2 here because s plus 2 equal to 0 gives s is equal to minus 2 here. S plus 3 equal to 0 gives s is equal to minus 3. So I put s is equal to minus 3 in this remaining term, and I get minus 1. So here I will have minus 1. Is this clear?
Yes, ma'am.
So this thing now you can use only for these kind of quadratic denominators. Otherwise, you'll have to use that regular comparing method. So now we have ys to be equal to this. Let us find the inverse Laplace transform. So I will have yt is equal to e raised to the power of minus 2t ut minus e raised to the power of minus 3t ut. Is that clear?
Yes, ma'am.
Now, since we were talking about Laplace transform, so let us also write the ROC for this. So for x of s, it is real of s greater than minus 2. And for this, tell me the ROC.
Greater than minus 3.
Yes. So for y of s, the ROC will be intersection of both x of s and h of s. So real of s greater than minus 2 intersection real of s greater than minus 3. So this is a right-sided signal or a causal signal. So its ROC is going to be right-sided. So it will be to the right of the rightmost pole. So this is my complex plane. Here I have minus 2. Here I have minus 3. So which is the rightmost pole?
Minus 2.
Minus 2 is the rightmost pole. It is to the most, it is the most, I mean, it is the rightmost pole. Now ROC will be to the right of this. So this will be my ROC for the Laplace transform. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, now let us move to next question. So you have to find integral minus infinity to infinity sinc square t dt. I will give you the Fourier transform pair for sinc square. So I will give you this. Okay, let me write it first. A times 1 minus mod t by capital T. Can someone tell me which kind of function is this? This one?
Rectangle.
It is a triangular function. We discussed it in the very beginning. So I will draw this function for you over here. It is like this. Minus t to t is 0. Amplitude is A. So this is the analytical representation. This is the graphical representation of the same function. Is that clear? So the Fourier transform of this triangular function is at sinc square ft, or you can replace f by omega by 2 pi. So at sinc square omega by 2 pi into t. Is this clear?
Yes, ma'am.
So now I've given you this Fourier transform pair. So the Fourier transform of a triangular signal will be a sinc square, and by duality, sinc square will have a triangular, but there will be some scale factors and all. So you have to use this and tell me the value of this integral. And apart from this Fourier transform pair, you will also be using capital X of j omega is equal to minus infinity to infinity xt e raised to the power of minus j omega t dt. So here xt will be sinc square t, and if you put omega equal to 0, you will get this integral which you have to evaluate. Is the question clear and the hints clear?
Yes.
Okay, then take 2 minutes and then I will start solving. Do you want 2 or 3 minutes?
Ma'am, first kindly explain the questions once, the concept of this duality and the reverse of Fourier transform, and the by duality it's rectangular, a triangular.
Okay, so is the question clear that this is what you have to find out?
Yeah, that is clear, but
And
the thing is this,
in the first
in the
question,
second line.
this is what we used to solve. We put omega equal to 0 to get this integral, right?
Okay, ma'am.
So this is what it is. Now you will need, this is xt, sinc square t is xt. So to find this integral, you will need the capital X of 0, the Fourier value of Fourier transform of this at omega equal to 0. Is this clear? Or maybe, okay, let me solve this question. So here my xt is equal to sinc square t. This is from the question. Is this clear?
Yes, ma'am.
Now we have xt. This is the Fourier transform equation that we have. This is the Fourier transform equation, all right. Now I will put omega equal to 0 here. So I will have capital X of 0 is equal to integration minus infinity to infinity xt dt. Is this clear?
Yes, ma'am.
Yes, ma'am.
Now my xt is equal to sinc square t dt. So if you now see the question, this is what we have to calculate. Sinc square t dt minus infinity to infinity. Okay? Is that fine?
Yes, ma'am.
Now this integral is equal to the value of Fourier transform at omega equal to 0. So we need the Fourier transform of this signal. I gave you the Fourier transform, this one. So now if I see my time domain signal, it is equal to sinc square of t. But the relation that I gave you here, this is triangular function in time and the sinc is there in frequency. So what do we do in such cases? We use the duality property. So if we use the duality property, we will have AT sinc square. So I am actually using F. I hope that is fine.
Yes, ma'am.
Okay, or maybe let me just use the second one only, this one. So AT sinc square, omega will be replaced by T, T by 2 pi capital T. This will have the Fourier transform 2 pi. And if you see this triangular signal, is it an even function?
Yes, ma'am.
Others also, are you able to see that
Yeah,
triangular
yeah.
function is
Yeah,
an even function? So if it is an even function, then triangular of t will be equal to triangular of minus t. Is that clear?
yes, ma'am.
Yes,
So in
ma'am.
the duality, now we make it actually minus, but since here it is even, so it will stay as it is. So 2 pi into a 1 minus mod of omega by capital T. This is what we have. Is this clear? Just the duality property usage. Class is
Okay.
clear?
Yes, ma'am.
Okay. Now, what we will do is we want to find the Fourier transform for sinc square t. So let us try to create this here. So what we will do inside, to make it t, I will make capital T to be equal to 2 pi. Can you see that?
Yes, ma'am.
Now, let us come here. So here amplitude is 1, right? So this has to be 1. So capital A into T is 1. Are you following?
Yes, ma'am.
So T I found out to be 2 pi. So capital A will be 1 upon 2 pi. Is that fine?
Yes, ma'am.
So now we have these values and we converted this to sinc square T. Now let us try, let us see what Fourier transform will I get. So 2 pi into capital A, which is 1 upon 2 pi, 1 minus mod of omega, capital T is how much? 2 pi. So this is what I have. This and this cancels. I have 1 minus mod omega 2 pi as the Fourier transform of sinc square t. Is this clear?
Yes, ma'am.
Others also, are you following?
Yes, ma'am.
Okay, so now I have the Fourier transform of this. So now the value of this integral, let me write down the integral again. Integration minus infinity to infinity sinc square t dt will be equal to the value of the Fourier transform at omega equal to 0. Is this clear?
Yes, ma'am.
Now I have the Fourier transform as 1 upon, sorry, 1 minus mod omega by 2 pi. I have to put omega equal to 0 here. If I put omega equal to 0, what will I get?
1.
Others also, are you able to see this? Jay, Sonali, Rohit, Pratham, are you able to
Yes,
see
ma'am.
this? Okay.
Yes, ma'am.
So now we have 1. So we got the answer, which is 1. So another thing na, that you can remember is sin square t has a Fourier transform 1 minus mod f, or if you write it in terms of omega, this. And if suppose you have some, uh, a t or something, so you can use the scaling property to get this, the Fourier transform. Okay, anyways, now let us move to the next question. So you have this signal e raised to the power of minus 2 mod of t. You have to find the Laplace transform of this. So let me give you some hint and then you can start solving. Question, are you able, is the question clear? There's a signal e raised to the power of minus 2 mod t. We have to find the Laplace transform. Question is clear now?
Yes, ma'am.
Okay, so now let us break down this modulus. So what will I have? E raised to the power of minus 2t. When t is greater than 0, it will be as it is. So I can write ut. Then when t is less than 0, it will become 2t and it will be u of minus t. Is this clear?
Yes, ma'am.
Now, the Laplace transform also satisfies the linearity property. So, the Laplace transform of this will be equal to the Laplace transform of this plus the Laplace transform of this. Is this clear?
Yes, ma'am.
So, now I hope now you will be able to solve. So, take 3 minutes and quickly tell me the answer and also tell me the ROC. You have started solving now?
Yes, ma'am.
Okay.
And first it is 2s divided by s square minus 4.
What? Please tell me your answer again.
Uh, 2s divided by s square minus 4.
No, no, it is slightly wrong. Check it again. So these Laplace transform pairs I have written down in blue. If you refer to them, then I guess you will be able to solve.
And there will be minus before that second one.
Yes, that was what we discussed in the beginning now. There is a minus sign for this. This is what we discussed now, that why it is not going to infinity. This Laplace transform and this are equal, and these are the functions and the ROCs.
So we will get minus 4 divided by s square minus 4.
Minus 4 divided by s square minus 4. Yes, that is correct. And ROC?
Uh, for the first one, it would be greater than
No, no,
minus.
no. Tell me the combined ROC.
minus 4 to 4.
Yes, that's correct. So shall I start solving or others also need time? So Nali, Rohit, Pratham, Diksha, Rudra, you want
Yes,
to solve?
madam. We have done. Yeah, you can solve it.
All right, so let us see. So we had this signal e raised to the power of minus 2 mod t. We broke it down in terms of ut and u of minus t for t greater than 0 and less than 0. And by the linearity property of Fourier Laplace transform, we have the Laplace transform of this is equal to Laplace transform of this plus this. The Laplace transform for e raised to the power of minus 80 ut is 1 upon s plus a. ROC is real of s greater than minus a, and minus e raised to the power of minus 80 u of minus t also has the same Laplace transform, but its ROC is less than minus a. So if you see, this is actually a two-sided signal extending from minus infinity to infinity. Are you able to see this, that it is a two-sided signal?
Yes, ma'am.
So from our discussion of week 11 summary, if it is a two-sided signal, then the ROC will be a rectangular strip, and that is what we will get. So let us see. E raised to the power of minus 2 ut, the first term, this one, will have a Laplace transform 1 upon s plus 2. ROC will be real of s greater than minus 2. The second term is e raised to the power of 2t u of minus t. This will, so this with a minus sign has the same Laplace transform. So if we do not have a minus sign here, we are going to have it in the Laplace only. So this Laplace transform would be minus 1 upon s minus 2. Here it is 2, not minus 2. And the ROC will be real of s less than 2. Now let us add them together to get the Laplace transform of this e raised to the power of minus 2 mod t. So I will have 1 upon s plus 2 minus 1 upon s minus 2. We will cross multiply s plus 2, s minus 2. We will have the cancellations and we will have minus 4 upon s square minus 4. Let us absorb the minus sign. So I will have 4 minus s square. Now the ROC will be the intersection of these two. Real of s greater than minus 2 intersection real of s less than 2. So let us draw our s plane. So I have one pole at minus 2, another pole at 2. ROC is greater than minus 2, less than 2. So this is the ROC, which is a rectangular strip. Is this clear?
Yes, ma'am.
Okay, next question.
Yes, ma'am.
So you have an LTI system and the input is x of t is equal to e raised to the power of minus 5t ut plus e raised to the power of minus beta t ut. What constraint should be put on real and imaginary just let me write the statement of this question, then we can go back to the previous question. What constraint should be put on real and imaginary value of beta such that ROC of x of s is real of s greater than minus 3? Okay, so Jay,
Yes, ma'am.
we had these two signals, we were adding them. It was your doubt only, na Jay?
Yes, ma'am. Mine.
Yeah. So these are the two signals we were adding. This was the ROC of the first one. This was the ROC of the second one. The ROC of the of their sum will be intersection of these two ROCs. Are you able to see this?
So the ROC will be the final ROC from means I mean to say, then we can take the final ROC from the last equation, that is 4 minus upon 4 minus s square. It should not be minus 4 to 4.
So if you find out the roots of this equation, what will they be?
Yeah, 2 minus 2.
So this is what we
Oh,
have. Is it
I think
clear?
I'm stuck something. Okay. I don't want now understand, ma'am.
Okay, so let us move to the next question then. There is this signal xt is equal to e raised to the power of minus 5t ut plus e raised to the power of minus beta t ut. The question is, what constraint should be put on real and imaginary values of beta such that ROC of x of s is real of s greater than minus 3? Do you want me to solve or you want to try it?
No, I will try it once.
Okay, take 2 minutes. So maybe you can start by writing x of s expression, writing the individual ROCs, and then see the constraints then.
First, I think beta would be equal to 3. No.
You're kind of slightly correct. In question, so constraint was on real and imaginary values. So think in terms of real and imaginary values.
Ma'am, I did it something, but you do it. If I'll be correct, then answer.
Okay, so now 2 minutes are over. So let me also start solving. So xt is sum of these two signals. So their Laplace transform will also be the sum of them. So for the first one, can someone tell me what will be the Laplace transform of this one?
1 by s plus 5.
Yes, 1 by s plus 5. And similarly for the second one, it will be 1 upon s plus beta. Let us first find the ROC for the first one. So it will be real of s greater than minus 5. This is clear.
Yes, ma'am.
Now for the second one, ROC will be real of s greater than negative real of beta.
Yes, ma'am.
So
That's
let us go back to this ROC. So here there is constraint on the real values, but imaginary values can go from minus infinity to infinity. So on imaginary values we don't have any constraint, but for real values we do have. So let us come back to this question. I want the ROC to be real of s greater than minus 3. This is what I want. Let us quickly draw the S plane. So I have one pole at minus 5 and another at uh, negative real of beta, right?
yes, ma'am.
Now, these both of them, there is ut. Ut means causal signals, right-sided signals. So ROC has to be right-sided. Now, if we take their intersection, then this is what we will have. And since we want this, so that means real of beta has to be equal to 3. If it is 3, then minus 3 will come here, no? If it is real of beta is 3, then minus 3 will come here. So real of beta is 3. And on imaginary values, it can go from minus infinity to infinity. So we don't have any constraint on that. So real of beta is 3. Imaginary of beta can have any value. Is this clear?
Yes, ma'am.
Okay. Now let us move to the next question. You have a signal xt which is given by e raised to the power of minus 5t ut. It has a Laplace transform x of s. You have another signal gt which is equal to capital A times e raised to the power of minus 5t u of minus t. Let the Laplace transform of this be capital G of s. So you have to tell me value of capital A such that G of S and X of S, that is the Fourier transforms, have same algebraic form. Is the question clear?
Yes, ma'am. So, ma'am, simply A would be 1.
Uh, just see it carefully again.
-1.
Yes, that's correct. It will be minus 1. Why is that? Because here we have u of minus t. So a minus sign also comes. Okay, let us write. So what will be the expression for x of s? Tell me.
1 by S plus 5.
Yes. X of s is 1 by s plus 5. Let us go to g of s. So here we are not concerned about ROCs because we want them to have same algebraic form. So that is what we are concerned about in this question. So for g of s, it will be minus a upon s plus 5. Is this clear?
Yes.
Now, for them to have same algebraic form, a has to be equal to minus 1. Is that clear?
Yes.
Others also, Jay, Pratham, Rudra, Sonali, Rohit.
Yes, ma'am.
Yes, ma'am. Clear.
When
So,
we were, ma'am, can I ask?
Yes.
Ma'am, when we were solving this question,
Mhm.
where when we are putting the minus infinity, it was going to infinity. So it was the second term, so that went to 0, and the first term was e to the power something. When we are putting the 0, it was turning out to be 1 by s plus a. So where that minus was?
Okay, let us go back. So we first computed the Laplace transform of e raised to the power of minus 80 ut. It turned out to be this. Is this clear?
Yes, ma'am. Yes, ma'am. That's why it is
Now
positive
let us
1 by
see the
s.
second one. So here we were computing the Laplace transform of minus e raised to the power of minus 80 u of minus t.
Oh,
Are you able to see this? So for this minus e raised to the power of minus 80 u of minus t, I got 1 upon s plus a, and this was the ROC. So here there was this minus sign already there. That is why it is coming. If it is not there in xt, then it will go to the Laplace transform. Is this clear, Ananya? Okay. Now this question. So here you have to find poles and their order. You can also tell me zeros. So there is this transfer function h of s which is equal to minus 100s divided by s cube plus 12s square plus 21s plus 10. You have to tell me poles and zeros of this system and also their order. The question is clear now?
Yes, ma'am.
Okay, so what are the zeros? Zeros are the roots of the numerator polynomial. What are poles? Poles are the roots of the denominator polynomial. And the order, the number of times that root is repeated, that is the order. So is the question clear to everyone?
Yes, ma'am.
Okay, then take 3 minutes and tell me the answer, and maybe we can keep this as the last question. Start solving.
The zeros are. Should I tell or not?
Tell.
So zeros are 0, and the pole would be plus minus 1 twice, and minus 10.
Yes, yes, that's correct. Others have also solved. Jay has
Yes,
solved.
ma'am.
Sonali, Rohit, and Rudra, have you solved?
No, ma'am, not yet.
Okay, okay. Some time is still left. Solve. Do you want to solve more questions, or let us keep this as the last question?
More.
Okay,
More, ma'am.
okay, okay. Should I start solving this question? Sonali, Rohit, Rudra, should I start solving this question?
Yes, ma'am.
Okay. So let us first see zeros. So zeros are the roots of the numerator polynomial. Numerator polynomial here is minus 100s. So the root is s equal to 0. And since it is there only once, so order is 1. This is clear now?
Yes.
Sonali, Rudra, Rohit, is it clear?
Yes, ma'am.
Okay, now let us move to poles. So we see that this is a cubic equation. So first we find one root by hit and trial, and for the next root we use the division process. So let us take s is equal to minus 1 and see what we get in the denominator polynomial. Minus 1 cube plus 12 times minus 1 square plus 21 times minus 1 plus 10. So this is coming out to be 0. Are you able to see this?
Yes.
So that means s is equal to minus 1 is a pole. Now let us find out the other roots. So for other roots, I will do s cube plus 12s square plus 21s plus 10. I will divide it by s plus 1. And so I request you to please perform this division yourself. And once you perform the division, so the question that you will get is s square plus 11s plus 10, and the remainder will be 0. So now we have this new denominator polynomial as s plus 1 into s square plus 11s plus 10. And if you factorize this second quadratic, you will get s plus 1 into s plus 10. So what do I have? S plus 1 square times s plus 10. So one pole is s equal to -1, which is of order 2. The other pole is s is equal to -10 of order 1. So poles -1, order 2, -10, order 1. And if we were to plot the poles and zeros in the s plane, so at -1 we have 2 poles. At -10 I have 1 and 1 0 at s equal to 0. Is this clear?
Yes, ma'am.
Okay, next question. So I have 3 more questions. So let us do. And so do you want to take one question as homework or you want to solve here only?
I'm here.
Okay. So the next question. A stable LTI system has a transfer function h of s which is equal to 1 upon s square plus s minus 6. To make this system causal, it needs to be cascaded with another LTI system having a transfer function h1 of s. A correct choice for h1 of s among the following is, there are 4 options. First option s plus 3, second option s minus 2, third option s minus 6, fourth option s plus 1. So is the question clear?
Yes, ma'am.
For the first question, we have this transfer function, and this system we want it to become causal. So for that, we will cascade it with another LTI system which has a transfer function h1 of s, and we want to find the correct expression for h1 of s among the options. So when we cascade, so in time domain there is convolution, and when we cascade, then in frequency domain there is multiplication. So yes,
Can you repeat it again?
the question.
The thing you said. Just...
Okay, so when we cascade two systems, then in time domain there is convolution. Are you able to recall this?
Yes.
And when we go in frequency domain, then that convolution turns into multiplication by that property, right? A convolution in time is multiplication in frequency. So by that property, it becomes multiplication. So that is what you will be using here to solve this question. Is it clear?
Yes.
Okay, start solving. Take 2 minutes. So others solve, and Rohit is asking me, why are we finding poles and zeros? Okay. So when we find poles and zeros, then we are able to characterize the system better. Like when we were discussing Bode plot, then by adding zeros or poles, we can, make that transition sharper. So when we know the poles and zeros, then we can better manipulate the system according to our needs and also better understand it. No, it is not C, Ananya. Try again. Yes, Jay is correct. After 1 minute, I will start. Shall I start solving now?
Yes, ma'am.
Yes, ma'am.
I think you have not studied about stability, now that uh, this LTI system is stable if it contains the j omega axis in its ROC. Have you studied that?
No, I think.
Mm. Okay, so I will solve this question, and once you go through week 12 contents, then you can come back to this question and look at it once again. Is that fine?
Yes, ma'am.
Sure, ma'am.
Okay, so let me write that statement. So, an LTI system is stable if the ROC contains j omega axis, the imaginary axis. All right. So H of S is given to be stable. Okay. So if it is stable, that means it contains j omega axis. All right. So let us take this expression for H of S, which is 1 upon S square plus S minus 6. If we factorize, we will get 1 upon S plus 3 into S minus 2. Are you able to see this?
Yes, ma'am.
Okay. So now we have this. Let us again do the partial fractions. Tell me the numerator for S plus 3 by the same method. You remember that method when we discussed in the beginning of the class. Tell me what will be the numerator for S plus 3.
Then is it 1 by minus 5?
Yes, minus 1 by 5. And for the other one?
1 by 5?
Yes. Now let us look at the ROCs. So for this, it is real of S greater than minus 3. Because if this is when this is considered to be causal, the first one. If it is not causal, then ROC will become real of S less than minus 3. If it becomes less than minus 3, can we ever have j omega in the ROC? If my ROC is less than minus 3, can I ever have j omega in the ROC? My pole is at S is equal to minus 3. If my system is considered to be causal I will have this ROC, that is real of s greater than -3. Right-sided signal ROC has to be left-sided. So if we have the first one, then this will become my ROC. But what happens if I take the first one to be non-causal? If it is non-causal, then my ROC will be real of s less than -3, right?
Yes, ma'am.
If it is less than -3, then it will be something like this. So if it is less than -3, this j omega axis will never ever come in the ROC. So that means that the first one has to be causal. Is this clear?
Yes, ma'am.
Now let us go to the second one. The pole is at s is equal to 2. So if it is causal, if I take this to be causal, then ROC will be real of s greater than 2. If it becomes greater than 2, it will again never have j omega in the ROC, right? Are you able to see this? Yes, Ananya? Ananya, you were saying something?
No, ma'am.
Are you able to see now that if ROC is real of s greater than 2, then it will never have the j omega axis?
Yes, ma'am.
So that means the second system has to be non-causal. So this will be non-causal. So will that means real of s will be less than 2. This will be the ROC for this one. Now when we take their intersection, it will be this rectangular strip, and if there is this rectangular strip, it will contain j omega axis and my ROC will contain j omega axis. So my system will be stable. So now we know that this corresponds to the causal part and this corresponds to the non-causal part. Now in the question, it was asked to make this causal. We want to make the system causal. So in order to make it causal, we have to remove the non-causal part. The non-causal part corresponds to this. So we want to remove this. And when we cascade the two systems, so this is h of s, this is h1 of s. When we cascade, they are multiplied. So h of s is multiplied with h1 of s. H of s was 1 upon s plus 3, s minus 2. What we got by factorization. Now, in order to remove this non-causal part, I will simply need to multiply it by s minus 2 so that I just have this causal part remaining. Is this clear?
Yes, ma'am.
So now h1 of s has to be equal to s minus 2. Let us go back to options. Do we have s minus 2? Yes. So this is the correct one. Did you understand this?
Okay, ma'am. Yes, ma'am.
Okay, so once you watch week 12 videos, now then come back to this question again. All right.
Yes,
Can we move to the next question? This one is based on Fourier transform. So x of t is input to an LTI system. The output y of t is given as 4 times x of t minus 2. So you have to tell me the transfer function of this system. What is he asking? Is anyone asking anything?
No, ma'am. I am giving reply to Ananya.
Okay, okay. So everyone understood this previous question, now?
Yes, ma'am.
Okay, so next question. We have xt is input to LTI system. Yt is the output is 4 times x of t minus 2. You have to tell me the transfer function. So what is the transfer function? H of j omega is equal to y of j omega upon x of j omega. This is what you have to tell me. Did you understand the question?
Yes.
Okay, start solving. Take 2 minutes. Okay, take 3 minutes. This is the second last question.
Ma'am, should I tell?
Sorry,
Should I tell?
you got the answer?
I think.
Tell me.
Is it 4 e to the power minus 2 j omega?
Yes, yes, that's correct. Have you solved this question before?
No.
Okay, okay. This was really quick. That's nice.
Ma'am, by that properties 4
Yeah.
and x j omega.
Mhm. Rudra, Sonali, Rohit, Jay, you also solve?
Yes, ma'am.
Should I start solving now? Rudra, Sonali, Rohit, Jay, should I start solving now?
Yes, ma'am.
Okay. So with this, we know that this is an LTI system. So for an LTI system, yt is equal to xt convolved with the impulse response, and the Fourier transform of impulse response hj omega is the transfer function. So we have 4 times x of t minus 2 is equal to x of t convolved with h of t. If we get back the same function with some shifting and scaling, that means h of t has to be a delta function, because convolution with delta function only gives me back the same signal. So by comparing this, I can say h of t is 4 times delta of t minus 2. Is this clear?
Yes, ma'am.
So if h of t is 4 times delta of t minus 2, hj omega will be equal to 4 times time shift property e raised to the power of minus j 2 omega, and the Fourier transform of delta t is 1. So this is what we have. And if we want to write it in terms of linear frequency and not the angular frequency, then I will have h of f is equal to 4 minus j 2 2 pi f, which is 4 times e raised to the power of minus j 4 pi f. Is this clear?
Yes, ma'am.
Sonali, Rohit, Rudra, Jay, clear?
Yes, ma'am.
Yes, ma'am.
Okay, so before we start the next question, it is not related to the next question, but this is something I want to tell you. So, if suppose there are n poles in my system, then the number of ROCs possible in the Laplace transform will be n plus 1. If there are n poles, the number of ROCs possible will be equal to n plus 1. Let us take the example of 3 poles. Suppose I have 3 poles. So we know that ROC cannot contain pole. So if ROC cannot contain pole, then the number of possible ROCs, one could be this, the other could be this, This could be one, this could be another one. So I had three poles here, and the ROCs, four ROCs are possible. Is this clear?
Yes, ma'am.
Okay, now let us solve the last question. So x of t is equal to 1 when t is between -1 to 1, and it is 0 otherwise. So can you tell me what kind of function is xt? Does it look familiar?
Rectangle.
Yes, xt is a rectangular function. So the question is, two of the angular frequencies at which the Fourier transform of xt is equal to 0. I will give you four options: pi, 2 pi, 0.5 pi, 1.5 pi, option C 0, pi, option D 2 pi, 2.5 pi. So I will give you some hint. Xt is a rectangular function. So the Fourier transform of xt is going to be a sinc function. So which are the values of frequencies for which the sinc function is 0? That is what you have to tell me. Understood the question now?
Yes, ma'am.
Okay, start solving. Take 3 minutes.
Ma'am, is it A option?
Yes, it is correct. If anyone else also gets the answer, please unmute and speak. Jay, did you not get the answer?
No, ma'am.
Okay, okay. Take your time. Actually, time's up. Can I start solving, please?
Ma'am, can I get 1 minute?
Okay, fine, take it. Yes, that's correct. Now let me solve, please. So everyone, please pay attention. The xt was given to be 1 between -1 to 1 and 0 otherwise. So this is how we can represent it, which is a rectangular function. Now we want to find the angular frequencies at which its Fourier transform is 0. So let us first find the Fourier transform of this. So if you remember how we used to represent rectangular signals, so xt can be written as 1 rect of t by 2. Is this fine?
Yes, ma'am.
Let me just draw it here. This is a, this is minus tau by 2 to tau by 2, and this is a rect t by tau. And so by comparing from that, we have this expression for x of t. And we know this Fourier transform pair a rect t by tau is equal to a tau sinc f tau, or omega by 2 pi. So let us write the Fourier transform. A is 1, 1, tau is 2, sinc omega by 2 pi into tau is 2. So what we have, the Fourier transform is 2 sinc omega by pi. Now at omega equal to 0, sinc is 2 sine pi theta upon pi theta. So this is what we have for the sinc. Now when we put omega equal to 0, we will get a 0 by 0 form, and ultimately the value is not 0 at omega equal to 0. Now we have sine omega in the numerator. So let us see option A, sine pi. What is the value of sine pi?
0.
And what is the value of sine 2 pi?
0.
So that means option A satisfies. Now let us also check option B. So option B is 0.5 pi, that is pi by 2. Is sine pi by 2 0? No, it is equal to 1. So this cannot be. Now at omega equal to 0, we get some finite value. It is not 0, so this also goes away. Now option D, sine 2 pi is 0, but what is sine 2.5 pi? It is not 0, so this also goes away. So our correct option is option A. Is that clear? Is that clear? Ananya, Sonali, इधर है?
Yes, ma'am.
All right. So this was the last question I had. Do you have any other doubt? Or we can just end the session then. Okay. Thank you everyone for joining. Have a great day.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
You too.
Thank you.